Hello all, welcome back to my channel. Please like and subscribe and press the bell icon so that you don't miss out on any of the upcoming tutorials. In my last video, I taught how you can search an element in a sorted and a rotated array in big O of log n time. In today's session, we will see how a node can be deleted from a linked list, and that too the middle node. So I hope you all know what is a linked list. So let's say for reference, this is a linked list, and we want to delete the middle node. The middle node here would be 3. Since there are 5 elements in this, so you always can say that n equals to 5 and the middle node would be n by 2. So the middle node is always n by 2 irrespective of the number of nodes, whether it is even or odd. Middle node is always n by 2. If it is just 4 elements where n is even, n equals to 4, in that case also the middle element would be n by 2, that is equals to 2. So in that case also we will need to be deleting this element 3. In linked list also we will mark it as, or will start numbering from 0, 1, 2, similar to an array. So in the first sequence, after deletion of the middle node, the new linked list would look like this. And in the second case, it would be looking like this, 1, 2 and 4. Okay. Now there are 2 ways to do it. One you can think of is, you can always travel the linked list and keep a count of the number of nodes. So while traveling the linked list, you will just keep on incrementing that counter. And once you reach the end where next pointer is null, you can say, okay, these many, this is the count of the nodes of the linked list. You can simply do n by 2 and then traverse the linked list again and just delete that particular node. So in this case, you have to traverse the linked list twice. I'll tell you a way in which you can delete the linked node in delete the middle node of a linked list in just one traversal. Let's see how. So let's understand this with the help of an example, how you can do this in a single traversal of a linked list. So I'll continue to my initial example. Let's say this was your original linked list. So we will have 2 pointers, slow and fast. This would be a slow pointer and this would be a fast pointer, which would be initialized to head. Okay. Now what we will be doing is, we will be moving the slow pointer by 1 and fast by 2. So your slow will be pointing to this and fast will be pointing to this. This would be your fast pointer and this would be your slow pointer. Now again, what will you be doing is, you will be moving slow by 1 and fast by 2. So your 3 will become the new slow and fast pointer will become 5. So fast will be pointing to 5. In the next iteration, what will happen is, slow will start pointing to 4, but there is no space for fast any further because fast next is null now. Has become null. So there are 2 conditions to stop it. And you see that at this point the slow is pointing to 3. It means that the pointer or the node at which slow is pointing, that needs to be deleted. So there are 2 conditions. Either fast next should be null or fast itself should equals to be null. How? Let me show you when this condition will occur. Let's say the number of nodes in the linked list were even. In that case, what will happen? This was your slow and this was your fast. This was also the head. So slow will be pointing to this. This would be your slow and this would be your fast. Now slow will be pointing to 3. This will become your slow and fast would become null because 4's next was pointing to null. So this is your fast, that would be pointing to null. In this case, fast has become null and your slow pointer is pointing to node number 3. So that node needs to be deleted. I hope it is clear till now. So let's see with the help of an algorithm how we can achieve this. So this would be like delete Sorry, I'll change the color again. Delete mid node, and the input would be the head. The way we represent a linked list is through the head pointer. Okay, so we will have some few base conditions. If head is null, then we simply return null. And the return type for this function would itself be node, because we will be returning the head. If head is null, then return null. If head's next is null, let's say there is just one element in the linked list. So we have checked for no element, then we are checking for the next element. Then what we need to do is we just need to remove the head. So we'll mark head as null and just return the null value. For all other conditions, we will be proceeding further. So we will be having 2-3 pointers as slow. One would be slow, one would be fast, and one we have to keep a counter of the previous value, because in this, when you have reached the value that okay, you want to delete this slow node, in that case, how you will do that? You will mark 2's next to 4. So for that, you need to know the previous of the slow. So we will have to keep a track of the previous value as well, okay? And previous. All of these will be pointing to head. So slow equals to fast equals to previous equals to the head. Now, as I have mentioned earlier, we will be having two conditions to come out of this loop. While fast is not equals to null, or fast next is not equals to null. Okay. In both the cases, we will just end the loop. If not, if this condition is not true, then we would be doing is, before this, we'll be keeping previous. Previous equals to slow. Then we will move the slow pointer. Slow would be slow's next. And fast would be fast next nexts. It would be 2 next here. So we have one pointer we are moving twice and one pointer we are moving once. Okay. And once this condition has met, in that case what you are going to do is previous equals to slow's next. This would be previous next actually. This would be previous next equals to slow's next. And in the end, we will be just returning the head. So this marks the end of this algorithm. And in this case, we have just traversed the linked list once with no additional auxiliary space as well. Thank you for watching the video. Please stay tuned.